This is our worksheet in Geography 313 Pacific Northwest. Our summers in Western Oregon getting hotter and drier. And hopefully by now you've had a chance to read through this. I'm not going to read through it with you here, but I want to give you some very specific instructions somewhere near the end, and it'll look a little different when you get this because I'm still modifying this a little bit. I'm not quite done, but I wanted to record this YouTube. This is your data source right here. So when you click on this, you will come to something that looks like this eventually. And so this is where you'll find yourself. And what you want to do when you get to climate at a glance is you want to look across here. And since we're going to be collecting data for a sheet that looks like this, we need to find exactly where we're looking for. So we're going to do a state of Oregon first. We're going to get temperature data all the way down in all these regions for the state of Oregon, and then Western Oregon specifically climate regions. So we're going to go to the coast, Willamette Valley, Southwest Valley is looking on the left there, and the North Cascades. Okay, so that's more or less what Western Oregon is. And we're going to fill in the temperature trends for June, July, and August combined together. That's 3 months. Okay, so that's what we're going to fill out. So we need to go get some data for the state itself. Overall average for the whole state. So here we go. Statewide, we want a time series. This is over time. And so we click there, and I'm going to run down here. We want average temperature. We want a 3-month running average, and what we've got is June, July, and August. Those are considered the meteorological summer, so we're going to use those 3 months, and the way that you ask it for that is you say we're ending in August, and we want to do a 3-month period, which means we're starting in June. So June, July, August. And the start year, that's the earliest you can go back, as you can see, is 1895, huh? Wow. And the end year is 2020. That's this year when I did this, for those of you that are listening in 2020. And then we want to make sure we've got all this right. So we're going to have a base period, which we're going to compare our more recent trends to. And so we're just going to go back as far as we can. Why not? And then we're going to do trends, though, per decade, since we're going to be doing, we're looking at like 1960 to 2020. We want to know per decade what's the trend, and also 2000 to 2020, what's the decadal trend there per decade. So we're going to put those numbers in here once we find them. Okay, so that's where we're headed. And so in doing that, let's see, we want to start in 1960 per decade, 2020. So make sure all those are put in there properly, or you're going to get the wrong answers. I'm going to be really picky about this, so just make sure you get it right. Okay, we're going to plot it. Okay, and when you do that, that's what it will look like. 1895, and you're looking for temperature June, July, August, June through August, and you can see that it calculates nicely for you an average or mean temperature of 61.9 degrees, right about 62. So that's the average for the whole time period. Okay. And what we're looking at then is the period from 1960 through 2020. So here's our blue line. This is the linear trend line for that time period. And now look at all the ups and downs. There's a lot of them, but that overall is the fitted trend line, linear trend line rather, for that period. It's 0.4 of a degree per decade. So that's a big change, okay? We went from under 62 degrees to over 64. Wow, that's significant. Okay, so what we're going to do then is put this 0.4 degrees in the spreadsheet. So we'll put that right here, 0.4. Make sure you got 0.4, okay? Now the next thing we need to do is fill out 2000 to 2020. What's going on there, right? So we're going to go back to this, and we're going to give it a little different set of instructions now. We're going to go 2000 to 2020. So, hey, what's going on in recent years, since most of you were born, right? Some of you have to be a little careful with that one. So plot it, see what we've got. Okay, we're going to stay with this stuff here the same. Oh, excuse me, I did goof up here. I'm yakking, trying to be funny, and all I did was make an error. So we're going to always leave these this way for the temperature, and where I need to make the changes over here. Instead of 1960, it's 2000. Okay, 2000. So 2000 is what we're looking at for trends. 2000 to 2020. That's 2 decades. So per decade, what's the trend? All right. And again, same baseline time period. Let's plot it. Okay. So June through August. Now we're just looking at what happened here. And so that trend, interestingly, works out to be the same. We just fitted it from the year 2000 to the year 2020, and that's a linear trend overall, smoothed out of 0.4 degrees per decade. So pretty much a constant trend over since 1960. Nothing really changed in the last decade. It just keeps going up. Although look at this. If you just measured right here, that's a short-term down, isn't it? So that's something we're going to come back to later and talk about how long it turns we should even worry about or be concerned with. Okay, so another 0.4 we're going to enter in here. Boom. Now I'm going to give you one example of how to do the Palmer drought. Now the rainfall, see the next one here is rainfall, how we do rainfall for the state. I'll show you how you would do it, but I'm not going to enter the data. Instead of going average temperature, you just go precipitation. Same thing, okay? And in the summer, it's all rainfall, except on some of the highest mountains, and even then, pretty much. So we're just I'm calling it rainfall in this project, but technically it is precipitation if we're doing for the time of year when you could get something other than rain. And even in the summer, that can happen here too. So precipitation, fair enough. Now, we want to look at precipitation for those 2 time periods. So you want to change 1960 to 2020 like we did before, and then come to this again. So you have 2 data points that you will enter right here. We're not going to do those. Those are exactly like we did here with temperature. You just changed the rainfall. Okay, but now this next one's a little different. So I want to go here, the Palmer Drought Severity Index. That's what that means, and that's described a little bit in the assignment. And we're going to look at what we have on average in August. And that, by the way, is shaped by data long before June. It really goes way, way back hydrologically. So it does tell us kind of the status of moisture availability in August. That's what it's designed to do. So let's look at that. Okay, so what we're going to do now, we're going to change this to Palmer Drought Severity Index, PDSI. And so now we are interested to see how it changed from 3 months to 1. It won't let you do 3 months. It won't do 1 month at a time, and then it calculates all the months before that to get us to where we are in August in this case. So same start year. I believe it is, and maybe it'll change. I think it does change a little bit because they have a little more data needs. But let's see what happens there. In any case, and we want to do it for first the 1960 period as we did before. Okay, and then in 2020, and we want trend per decade. And that's a little harder to interpret, but it will stay consistent at least on that, so we can make some comparisons. And let's plot that. Okay, so we have then a trend with drought severity that is getting more severe. In other words, starting in the mean is roughly 0, which is what it's supposed to be. Okay, and any value above the line, a green bar is wetter, and the orange bars are drier. Okay, so interestingly, even looking at this, you can see it definitely has a trend downwards, 0.27, negative 0.27 per decade. Negatives, again, orange values, are getting drier. So negative 0.27 per decade from 1960 on. So I'm going to go negative 0.27. And then I'm going to do the same thing for the 2000 to 2020 time period. Go right up there, up 2000, and we are going to plot that. Okay, so we've got drought severity index, August, baseline, per decade, year 2000, 2000 to 2020. Got that? Okay, plot it. All right, so now here's what's interesting. If you go, this is looking at down below. See that? That's year 2000. So that's where we started. You can see that with the blue line. And over that time period, how many different months were below 0. In other words, the mean value. Almost all of them except for 4. So 16 were drier than the long-term since 1895 calculated drought index. So the trend itself is towards a little less drier. What does that really mean? Well, this is the problem with shorter term. Okay, the longer term, it's harder to have a trend going opposite of the overall long trend. You saw before, it was basically getting drier. We started up here, and or like right about here, and it ran down this way, didn't it? Okay, but in short term, it's real sensitive to which years you choose, right? And so this is always something in data. If you want to talk about trends, the longer time period you have, in some ways, the better. This is a real trend for this time period, but it still remains quite dry, doesn't it? Okay, drier for almost all those years than the average. Okay, so that is then a plus 0.21. So you'd enter that in the database, right? Plus 0.21. Okay, now, real quickly, we're going to go look at how to do the rest of this. We're going to, since we need to now do regions, and the first one is a coastal area, let's go get that done. To do regions, we've got to go divisional. It'll take a minute here, and then we're going to do time series. Now, this basically means divisions within states or regions within states, subregions. So time series, same thing there, no change there. Now we're going to start out with, temperature, didn't we? So we're going to do average temperature again. We're going to go that 3-month thing just like we did before, but now it's for where? For the Division 1 or Region 1, the coastal area. So this is the Oregon coast. What's been happening out there? This is very interesting. If we go back to 1960, boom, we then plot this, and wow, temperature goes up 0.4 per decade. It goes from an average of well under 60 degrees Fahrenheit in 1960 on the trend line, and we're 62. Okay, so per decade, that's 0.4 of a degree. It's definitely a warmer Oregon coast. No question about it. Okay, so you'd enter 0.4 again. Interestingly, that's the same one we had for the longer term, though, isn't it? Okay, 0.4 again. So you could enter 0.4. I'm not going to do that there. And then you'll just do the 2021 as well. And that one is going to be something you probably noticed if you were watching there a little bit. Watch this. So now we're 2000 to 2020. And we plot that, and we get, wow, a smoking 0.9 degrees off per decade, really sharp. Remember, that's short term. Maybe we could have a few years to go back down, and it'll pull that slope down if that's the case. We'll see. Okay, we will see. In any case, we need to enter 0.9 there if we're going to be filling this out. So you would put 0.9 here. Okay, so uptrend, and then you're going to do the same for rainfall, and then you're going to do the PDSI just like you did before, where you do it for August, and then you do it for the next areas as well. You do the coastal area, so you're going to fill out 6 for each region, right? 6 data points for each region: coastal, Willamette Valley, Southwest Valleys in Oregon, and the North Cascades. So that gets us to Western Oregon. Okay, so that is what we're up to here. This is really a great source. I'm real excited about finding this for you guys because it doesn't really require a lot of work. The work is already done for you in the programs, but you can definitely see even at a glance what the trends are. That's what I'm wanting to understand. And so what are you going to find out? Okay, is it all we're getting warmer everywhere, or is it just a few areas? What about rainfall, precipitation? What's happening with our summer rainfall? And how does that turn us into either a drier Western Oregon or a wetter one using the Palmer Drought Index? That is what we're up to. I hope you find it interesting.